parabolas, your quadratic equations, and it's from the table on your calculator. So all you're going to do is find the vertex and 1 point on each side of your vertex to draw your parabolas. So you're going to need your calculators, right? Right? Calculators. Yeah. Everybody grab the calculators they came in. Yeah. I see some of you already started this worksheet.
How do we know where we are tomorrow?
It's on all the walls in all over the building, and your advisory today. Ask your advisory teacher.
So how long is it?
4.5 hours. Nope, you're done. You're going to go to lunch and then you're going to leave. Yep. Yep. Okay, so I should go. By the way, this is our parent function, isn't it? Y equals x squared. That's our parent quadratic function. You should know this off the top of your head. My vertex is at, well, if I plug in 0 for x, y is going to be 0. Plug in -1 for x, -1 squared is 1. So there's my 3 points. My vertex is going to be my 0, 0, because my y, I can tell that right off the chart because my y values start being the same after that point. So my vertex is 0, 0. My axis of symmetry is my x value of the vertex. So it's x equals 0. My domain for this course, for all of your parabolas, your domain is going to be -infinity, positive infinity. Let's draw. It's the last page of your packet. Alright, so if we draw our parabola, here's 0, 0, here's 1, 1, here's -1, 1. I like doing 5 points because I like having an accurate graph. If I plug 2 in for x, I get 4. 2 squared is 4. -2 squared is 4. Remember our axis of symmetries, right? The x value of our vertex. So go ahead and draw your parabola. Okay, let's talk a little bit about domain and range. Domain is all of my x values for the graph. Okay, now if I look at, so I'm looking at my x-axis. These are all my x values, right? Now, remember my graph here, although it's like an exponential function, it does go off to x infinity. Okay? If you could think of this as bending out a little bit more, it does go off into infinity for the x values. Okay? Same thing as I go to the right. That's why in this class, and even in Algebra 2, all your domains for parabolas, it's -infinity to positive infinity. It's not until you get to pre-calc that you're going to do different ranges for parabolas. What about my range? Now, what's range? They're the y values, right? So this time I'm looking at my y-axis here, which happens to be the axis of symmetry in this problem. So where's my least y value? You're looking at the y-axis and your graph. In fact, we call this point what? Not only is it the vertex, but it's the minimum. Okay? So if I ask you what's the lowest point, you should say, well, the minimum is 0, 0. Now I'm looking at my y value. It's 0 is the minimum. The highest point is going to be, it's going to go up forever and ever and ever, positive infinity. And it's as easy as that. Okay, now that was for the parent function. I didn't do this one. Okay, that's for y equals x squared. Let's look at some different quadratics now. Let's look at number 6. What am I going to do? That's right, put in my calculator. Go to your y equals. And put in negative 2x squared. Don't put in minus, put in negative. Hit graph. Go to your table. And they're actually giving us the points to put in here. So look for x at negative 1, negative 2, good. 0, 0, and negative 2 again. So I know that this is my vertex, right? 0, 0, because my y values start being the same. Axis of symmetry, x equals my x value, 0. Okay. My domain, gave you a hint, is always going to be negative infinity to positive infinity. We better go ahead and sketch this to figure out what the domain is. I'm sorry, for the range. So I have 0, 0. I know it opens down because of the negative sign. It's going to be a little skinnier because of the 2, because it's greater than, my a is greater than 1. So I have negative 1, negative 2, 1, negative 2. So it is indeed a little skinnier. Okay, what's my minimum y value here? What's my smallest y value? Now, if it goes this way forever and ever and ever on the negative, it's got to be negative infinity. Then what's going to be my highest point for y? 0, my maximum. And I'm done. Oh, they want us to graph the axis of symmetry too. There's my axis of symmetry. How about number 8? I'm going to put my equation in, negative, so it's going to open down. It's going to be skinnier because my a is 3. So I got negative 3x squared plus 6x minus 1. And hit graph. Notice my vertex is no longer at 0, 0. Notice I have an extra term here. You should be making some kind of connection that this is going to tell us something about our vertex. We'll get into that later. All right, go to your chart. 0, negative 1, 1, 2, and then 2, negative 1. What's our vertex here? Yeah, It's going to be 1, 2, right? So that's our vertex. So let's graph this. 1, 2, 0, negative 1, and then 2, negative 1. Okay, axis of symmetry is my x value of the vertex. So x equal 1. So here's my axis of symmetry, x equal 1. It's the equation of that vertical line. Domain, we're lucky because it's always negative infinity, positive infinity. Now my range, I have a maximum. What's my y value? Well, first of all, it starts at my smallest number, negative infinity, because it's on the bottom here. I have a maximum. What's my maximum value here? Be careful. It's 2, right? Who said that? Good, Nick. My y value is 2. Or it's the y value of my vertex. There's a lot of stuff that's you can get off of just points from a parabola. Are you guys copacetic? Okay, the next page, it says use negative b over 2a to find the axis of symmetry. We're not going to do that right now. Okay, we're going to do that when we get into factoring. So we're just going to use our graphs on the calculator. Let's try number 13. So I have x squared plus 2x minus 3. Graph it. I'm going to go to my table, get our values here. Let's see, negative 3, 0, negative 2, good. Negative 1, 0. Okay. What's my vertex here? Anybody? A couple of different ways you can find this out. Negative 1 minus 4, just by looking at this, because these two are repeating, and these two are repeating. So I know that negative 1, negative 4 is my vertex. So that's one way. And then back in 10.2, didn't I show you guys how to find the min and max? That's your vertex. Okay. The vertex, this happens to be what? Min or max? Min. So I'm going to go to second trace, calculate my minimum, hit enter. I got to find a left bound, get to the left of the point, get to the right of the point, and then hit enter. And it tells me it's 1, negative 1, negative 4. See it? Negative 1, negative 4. Now this problem happens to be easy because we were able to read it off the chart. Guess what some of these problems are going to have? Yeah, decimals. So your number's not going to be in the T-chart. So you're going to have to do left bound, right bound for some of these. Be careful. -1, -4. So -1, -4 is my vertex. 0, -3. 1, 0. And I'm just going to use my axis of symmetry. Actually easier is x equal -1, right? My x value here. And because it's a symmetry, I'm just going to go 1 away from here. See, this one's 2, so I'm going to go 2 the other way. It's easier than graphing. Here's my parabola. Let's not do any absolute value yet. We'll get to that. So 16, 17, and 18 you don't have to do. And we're good. So you only have 1, 2, 3, 4, 5, 6, 7 problems due. Should be able to finish that in half an hour. And when you're done, you can turn this whole packet in for credit. ¿Comprendes? Anyone? Questions? Comments? Concerns? Anyone? 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 You